Assume that you have a Boolean expression of the form ABC or AB prime C prime or A prime BC or A prime B C prime and so on. Okay, now it's very difficult to come to the simplified equation using Boolean laws or theorems. You can easily miss some theorems, or you might you might pair up the wrong combinations, or not exactly the wrong combinations, but not the most efficient combinations, and your final expression can be not in the most simplified form. To get the expression easily in the most simplified form, we use something known as K-maps or Karnaugh maps. So using Karnaugh maps or K-maps, we can avoid using Boolean theorems and laws. It's a much more simpler method. Let's take two variable K-maps. Okay, so if you have a function, let's say f of a comma b, the K-map for f will look as follows. It's going to be a box and a line here. Now f is a function of a and b, so you have a here and b here. We know that a can assume the values 0 and 1, so 0, 1, and we also know that b can assume the value 0, 1. Therefore, this cell corresponds to the situation where a is 0 and b is 0. This cell corresponds to the situation where a is 0 and b is 1. This one would be a is 1 and b is 0. And this cell corresponds to a equals to b equals to 1. That is, both a and b are 1. Now let's see how we can use this graphical setup to simplify Boolean expressions. Let's take an example with two variables a, b. So 4 combinations. And your f is 1 and 1 for the first 2 combinations and 0, 0 for your next 2 combinations. Let's try to fill up the, actually, let's first try to simplify this Boolean expression using Boolean laws and theorems. So your f is a prime b prime or a prime b. Now what you would have done is taken a prime as a common term and written b prime plus b, which is nothing but a prime. Now this is a simpler truth table. It just involves 2 variables, so it is pretty easy. And as you know, if you have a longer truth table, it can get really tough. Let's try to solve the same problem using K-maps. So let's draw the K-map. We have 2 inputs, A and B. A can take 0, 1, B can take 0, 1. Now when A equals to 0 and B equals to 0, F is 1, which corresponds to this cell here. When A is 0 and B is 1, F is 1 again, which corresponds to this cell. And for the other 2 combinations, you're going to get zeros. So the concept of K-maps is you can pair adjacent ones. You can pair multiples of 2's. So you can pair either 2 1's or 4 1's, 8 1's, and so on, or even 1 1, which is basically 2 raised to 0. And the third thing is cover as many 1's as possible. In each grouping. And the fourth one is overlap is allowed. So we're going to look at 3 and 4 in future examples, but let's just follow the first two rules here. Now you can pair adjacent ones. In this case, you have two adjacent ones, which are the two ones here. And your F equals the common term among the pairings. Now, B is not the common term because B is changing from 0 and 1, so it's not being constant. However, A prime is the constant term, that is A equals to 0 is the constant term. So we write F equals A prime. Let's take one more example to better understand this. Now my truth table is as follows. We have 0, 0, 0, 1, 1, 0, 1, 1, and F is 1, 1, 1, 0. Draw the K-map. A can be 0, 1, B can be 0, 1. So F is 1 when A equals to B equals to 0. F is also 1 when A is 0, B is 1. F is also 1 when A is 1 and B is 0, and it is 0 when A equals to B equals to 1. Now let's start pairing up. So to pair this up, we're going to take adjacent ones. And this one would be A prime, because A equals to 0 is the common term among those. Now we have only 1, 1 left. If we want to write it, you could have just written it as AB prime, because if you just take this 1, 1, the only common term is A and B prime, that's fine. However, to get the minimal form, we can combine it with the adjacent one. When you combine it with the adjacent one, you get B prime as the common term. Therefore, your F equals A prime or B prime. This is how a two-variable K-map works.